I think today is the day we're going to talk about Hyper-Converged Database.
Yep.
And more importantly, there's a poll out there, so go answer that real quick. The first poll of the thing. So how you been, Aaron?
I've been all right. I just did a week vacation in Miami. That was nice.
Very nice indeed. Yeah, did avoid all the hurricanes. Get back.
Yep. I ended up picking like the 1 week or so that didn't have. I like split the hurricanes. Right, there was one in Puerto Rico, and then there's another one evidently up way on the East Coast. But yeah.
'Tis the season.
Okay.
Don't go to Miami in the late summer, man. That's just hurricane season.
Well, again, that's me from Minnesota. What do I know about Miami, right?
Do you know why they don't put infrastructure in Miami or in Florida in general? That's a 100% chance of getting wiped out by a hurricane or a flood surge or something.
You're telling me there's no AWS East Florida?
Yeah, no, there will never be one either unless, there's the underwater data centers, right? Yeah.
Hey, that's a great
all
idea.
Right. Well, you know what? We need to get moving here.
Yes.
So today we're talking about getting started with Hyper-Converged Database. And so I think the thing that we need to start with here, which is the most important thing, is, let's talk about what Hyper-Converged Database actually is, right? And
good idea.
The first question for everyone is, why hyperconverged? And I hear that a lot. Like, wait a minute, that seems like a weird name, but hyperconverged is a word, and hyperconverged infrastructure is a word. But like, why are we using the word hyperconverged database? And I will explain and hopefully make this obvious, or at least understood by many. So it comes down to just this, which is managing resources and infrastructure now. And this is compute, network, and storage. And compute, network, and storage are what you pay for when you buy equipment, when you provision data centers, when you're renting it from the cloud. And the compute, network, and storage are those elements that need to be run efficiently. So if you're not using your compute, network, and storage in the most efficient manner, you're wasting money. And hyperconverged infrastructure and HCI has been around this, like combining those things together and making it as one unit. And how do we do that? No surprise, Kubernetes.
That's right.
Yeah, Kubernetes is if you hadn't heard, that was the poll that I put out there. Are you running Kubernetes or not? And if you're not, you should be thinking about it soon, or unless you just use straight up cloud stuff. But and that's fine too. But DataStax, we're very we're very bullish on Kubernetes, and to the point where we actually run a lot of Kubernetes. So our DataStax Astra is a cloud database, Apache Cassandra as a service, and it's essentially Cassandra running on Kubernetes, and we have something like 30,000 clusters running on Kubernetes. So it's something we're pretty good at, I think. Don't you think, Aaron?
I concur. Yeah, we're good at it. Yeah.
We're okay. I mean, it runs 24/7, and it's pretty amazing. We believe in it because what it does is it lets us run, and I'm getting to the point of why, but it's given us the confidence to build things and give you access to the ways of running Cassandra that are very cost efficient. Because as a cloud database provider, for us to give you a good price on using a database in the cloud that essentially could beat anything that you can do yourself, we have to be very efficient. And believe me, Aaron, how many meetings have we been in or been involved in where it's like, oh, we have to, do this efficiency on our cloud? I mean, for like every time. Yeah. So
no, for sure. Yeah. That being able to scale compute and storage separately really is key in terms of being efficient that way. For sure.
Yeah.
And when people say, when people say, hey, I want Astra, but I want it on-prem, I want it on my own. Well, I mean, ultimately, Kubernetes is what makes Astra kind of awesome. So
yeah. And Kubernetes is not just a thing that you have to run in your own hardware either.
Oh, no.
I like to make this point often that, Kubernetes won because all the clouds decided that, we want you to manage your compute, network, and storage using Kubernetes too.
Right.
So and that's why we use the word self-managed. You know, it's not on-prem always. You're running it yourself. And so, HCD is this is why hyper-converged is a thing. And this gets into this thing where we are at DataStax is, wherever you want to run Cassandra, we want to have something for you.
Yep.
And we have a lot of options. A lot of options. Yeah. All right. And this just happens to be, I'm going to dig into what it actually is. So besides running Cassandra and Kubernetes, what this is the products slide that I'm sure everyone loves to read, but it's what we did with Hyper-Converged Database, which is really important, is give you everything you need to be successful building applications with Cassandra. So there's different components, but one of those, like if you go further down, I mean, this is where the stack starts, is with mission control. Mission control is not the database. Mission control is the control plane for running HCD. And it's a separate install. It's something that you have to set up ahead of time. But what it essentially is creating this interface where you can create and destroy and modify your Cassandra clusters at scale.
And it makes it super easy to do too. And we have videos out there on how to use mission control, and the docs are pretty good. So yeah, highly recommend.
Yeah, and Aaron, you've created an entire playlist on mission control, if I'm not mistaken, or have you done that yet?
Yeah, I've done that. Yeah, that's out there.
Yeah, so mission control is a separate topic. We're not going to cover that today, but it is. I want to make sure it's well understood, because we're going to start using it.
You'll see some of
it. Yeah. But the running part, the database part of that, is Apache Cassandra, and it has a lot of DataStax enhancements, things that we've added to it. Many things that came directly from Astra that are now running alongside Cassandra, and I'll go into that in a minute. And then finally, it's the API gateway, which again we'll cover in a minute here. But thinking about it in terms of, instead of just like a port running in the cloud somewhere that you could connect to and good luck, we also think about developers in terms of how best they can consume data. And the data API, if you're not familiar with it, is a very cool, interesting way to run data on Cassandra without having to do data modeling.
Yep. And actually, if you've seen anything we've done recently on Astra, or we even have examples out there on how to use the data API with DSE 6.9, and Astra, of course. But yeah, we have tons of material out there on that too. But hey, now we're bringing it to the enterprise with HCD.
Yeah. And so the thing that you get out of this is, the things that are there, which are really important, are these storage improvements. A lot of this has to do with efficiency, right? If you look at what the value prop is for someone who wants to use Hyper-Converged Database, HCD, is around the efficiency. Like, storage improvements are really big. If you run a large Cassandra cluster, storage is the thing you need to solve, and node density, that sort of thing. We can do incredible amounts of storage efficiency with HCD, just the way that it runs in Kubernetes. You can save an enormous amount of money just on that. Walk away.
Yep.
And then the indexing support, it ships with storage attached indexes, which has been in Astra for quite a while. It will be in Cassandra 5, which, as of this recording, should be released anytime.
Hey, RC2 came out yesterday, so it's close. It's
close. Yeah. Vector search for Gen AI, and Gen AI, of course, is the word of du jour, and probably of the 2 years as I've been hearing it. And our vector search is based on JVector, which is quite possibly the best vector search indexing algorithm out there right now. And I have a slide on that. And of course, I mentioned mission control, which is doing, instead of having to do everything in a command line to run your Cassandra and Kubernetes, we have a nice little GUI for you, in which we will demonstrate. And the cloud native architecture is that, and so the version 1.0 that we're talking about today doesn't quite have all the storage and compute separation we wanted. That's a harder thing to pull off and into a supported package. But it exists, and we're going to have that shipping soon. It looks like a 1.1 thing. We wanted to get 1.0 out there so people could start looking at it and working with it, but that's coming. And vector graph will also be in 1.1. Vector graph is another way to do vector search, but with knowledge graphs.
Yep.
And like I mentioned, I think this is your number one reason. Aaron, how many people have you known that run just a little bit of Cassandra?
Most places I know run a lot of Cassandra.
Right. Yeah.
You're right. I've known a few that run like a small, few node cluster, but yeah, most places are running a lot.
Yeah, and that's where it adds up, and the TCO is about being efficient with the parts that add up. Of course, going faster, moving faster, being able to provision and run clusters quicker, and some of the things that we have that really make it easy to work with, but also that overhead, and what happens with like the storage, like reducing infrastructure cost by 20%. That's a pretty significant amount of money. And that's the thing you're paying for. That's the compute, network, and storage, right? And the way that we license, and this is because this is a pay-for product. This is part of our enterprise. This is an enterprise product. Part of our licensing is not based on node count. We don't do that anymore. We base it on resources. And I think that you'll find a significant savings trying to reason through how it goes more about like what you actually use. It's closer to how we price our cloud product, which is, hey, I need to use this much database. Well, that's what you pay for. That's how we chart it. Yeah. Did I miss anything in here, Aaron?
No, I don't think so. No.
Yeah. No. But yeah, so resource management is the key here. And then the vector search I just have to make sure that a vector is a separate. If you don't need it for Gen AI, if you just want to run your Apache Cassandra workloads, then HCD is good to go. There is a separate SKU, so it's a different charge for using HCD vector, but it's based on the same thing that's happening in vector, Astra vector, which is on our cloud product. And so if you go use Astra and you think it's awesome and you're like, I want that in a self-managed package, HCD has it, and it keeps up pretty well. And what it means when I say keep up, it's just the pace of development, and this is an important thing to realize, is the pace of development for JVector is just so fast right now. Yep. And I mean, Jonathan Ellis, who's working on this, I mean, oh man, I think Aaron, you could attest to that. He's just flying, right?
Oh yeah.
Yeah. I mean, I think they're on version 3 now, going to 4.
Right. In fact, they're evolving it faster than they can get it into Cassandra. Because I think when Cassandra finally releases with JVector, it's going to have like version 1 or something like that. But it'll be a couple of iterations behind what the latest and greatest is that we're using in Astra. But yeah, and it's moving really, really fast. And I think the thing that's really interesting too is that this is JVector this is like looking the future of HCD, will also be included in OpenSearch. That's something I keep hearing about, and OpenSearch will be included in HCD. So, it's really making it useful for developers. And then finally, like what are the use cases? Because that's the other thing we hear is it is. If you're using Cassandra now, I don't need to tell you what the use case is because you're probably already using it, right? Yep.
But Aaron, I think you've been building some newer things like Gen AI applications, right?
Right. Yeah. Anything you're doing in terms of like product recommendations is a really good use case for things that are driven under the hood by vector search. Of course, if you're building out like a chatbot for your site or a shopping assistant, again, that's going to have a a vector data structure underneath it as well. And that's really the cool thing that I think you get here is that that ability to have a path forward with some of the latest and greatest tech developments that are going on out there right now, for sure.
Yeah, and it's about moving fast. It's the modern stack. That it's developer ready. And we'll show that. And there's more to be said around developer ready. But if you're operating Cassandra clusters, we're in the same camp. We could hang out because we do the same thing. We build Cassandra clusters for developers to use in our Astra product. We also sell a product to help you do the same thing. And we're really successful at doing this. We have over 1,000 new databases created a week. It's a lot. Yeah. And thousands every week. And we do it efficiently, and we can show you how to do that. So that's where we're at. Okay, so I think, blah, 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 right? Let's get into some sharing here.
That's a good idea. This will be a little more exciting than just you and I talking, right?
Yeah, well, we had to get, you're exciting. I'm just a fucking head.
Right. Well, thank you, I guess.
I guess. Wait a minute, was that okay? All right, I'm gonna switch over to the demo-y part of this. So just hang on to your hats, everyone. This is the part where we do the live demo. So guaranteed something's gonna blow up. We got a question on here. HCD would do online upgrades
versions of DSD. Yeah.
You know what? You're right. And Dan, we're going to fix that. I know it's something that was supposed to be there, and there's just some issues, but we're going to fix that. You're right.
I know it's on the roadmap for sure. Yeah.
Yeah. You've been doing some online upgrade stuff, right, Aaron?
Yes.
Okay. So that's something that I think is going to happen pretty soon. And that's more in mission control, right?
Right. Yeah. The one that I've worked on is from DSE 6.8, which I know is way newer than DSE 5.1. But yeah, I know that the team is really working hard on getting a process out there for that. Dan's not the only one. I mean, there are so many people out there that are running DSE 5.1. So it's definitely a path that we need to have for folks.
Yeah, and kind of using it as a segue into the demo, we want you to use this button right here.
Exactly.
and have it work well with 5.1. Because for sure, I mean, if you're on 5.1, you're on a pretty old version of Cassandra. The upgrade just in changing code bases is going to be worth it. Especially with where 5 is at right now. 5 is just like an instant 20% performance increase, and that's more or less with the code we're shipping with HCD. So, so we're going to walk through a couple of things here. So this is mission control. We're going to do the Julia Childs thing. We already created one, so we already installed. This is already running. This is one of our internal HCD clusters, or I'm sorry,
mission control
clusters.
Yeah.
One of the things you need to do is you start a project. So I have a Patrick project because apparently I'm a project. There are a lot of projects in here. We'll switch projects in a minute, but a project is where you store your clusters. And so inside the project, I have no clusters in here right now. So we're going to walk through like what that means to create a cluster and go through some of the configuration. Because if you've used Astra, when you say create a cluster, it asks you like one question. Like, what is your favorite color? And that's it. There's a few more questions when you're creating your own.
Yeah, there's a few.
Yeah, a couple more. So Aaron, let's you and I walk through this real quick. Of course you're going to put in the name because of course I'm going to spell it. And then I'm going to pick HCD. Let's look at the first bit here. So version Yeah, go ahead.
You can. I was going to say you can specify a specific version. I'm pretty sure that HCD 100 is the only one we've got out there right now. But kind of the cool thing is that if you look directly under the version there, you'll see that we
Mhm.
have a spot where you can override the image.
Yeah.
And I'm trying to remember which Docker Hub repo it is, but you can go ahead and like kind of look where we have a lot of the
It's a
like
DataStax.
pre-baked mission
Yeah.
control images for all these
Mhm.
databases stored, and you can pick a specific one. So if we have one that's like in beta or whatever, you can go ahead and use that one if you want, if you really wanted to use beta. But anyway,
It's
yeah, you can totally override that.
Yeah, it's always good to have options, right?
Yep.
Well, and it'll be useful if we have alternative builds in our DataStax repo as well.
Yeah.
Um,
Yeah, absolutely.
I think if we had some hackers out there, which is probably about half the people, you could even deploy your own stuff. But
Probably,
good luck.
I think you can. Yep. Yep.
Yeah. Um, so I'm just going to use the default here. So yeah, so then we set up our topology. Again, with Astra, that's already kind of baked in, but this is where, because you're doing self-managed, you get to be in control of that, including multiple data centers. So let's go through some of this. So data center name, advanced workloads are as if you're using DSC. HCD does not have advanced workloads like Solar or Classic Graph. So those are not a part of it. What about some of these other settings that I should look at here?
You can also, specify your rack as well, which is usually a pretty good idea. And then, probably the other important thing too, and I forget where it is exactly, but there's a way to set up like a node affinity mapping, or a rack affinity mapping. So you can actually have like a specific.
Oh, it's right here. Yeah. So if I say,
yeah, there it is. There it is. Oh, I'm
say
sorry. I'm
rack
looking right at the
2,
broadcast, and the text is a little tiny.
yeah. So I can,
But
I can
anyways, yeah, that's where you can set up your rack to rack -1 to match up with like US Central -1 or something like that. You could predefine that.
So I've added 2 racks in here, so I'm going to say 3 nodes per rack.
Yep, you always want that to be a factor of your replication factor. Yep, that's right.
Mm-hmm. And look at there, I've got 6 nodes total that are going to spin up. Now, the question is, where is this going to spin up? We'll look at this in a minute, but this is mission control. When I say how many nodes I want, it's going to deploy that in my Kubernetes cluster that mission control is establishing. Yeah,
that's right. And in fact, you can specify that with the data plane control up above, because you can deploy your cluster direct to the control plane or to one of the other defined data planes that you have.
I think I got in trouble for putting it in the control plane last time. Yeah. For those of you who are looking at this name and going, what in the wild world of sports is that? This is Kubernetes.
Yep.
And it's because we're running in GK. This is Google Cloud. This is our Kubernetes. This is our Kubernetes environment for this particular setup. And so we have a setup with a label for this. So yeah, that's the data plane context. A lot of these concepts are in our docs, by the way. We're walking through these, and of course, reading the docs, there's a lot of these have deeper explanation. Also planning, like doing some cluster planning, that sort of thing. Yeah. Yep. Okay, host network. We're just going to say auto on this. I love this. Read the docs before you do anything different. It's like the Cassandra YAML that says, like, whenever your host IP address is never 00000.
It's never 000. Or it's 0000 is always wrong. That's what
always wrong. Yeah.
The comments in the YAML say. Yeah.
Yeah. So then we get into like the per node resource stuff. And what is there any gotchas in here that you need to think about?
I don't think so, other than whatever you set here is going to be consistent across all of your data centers. So it's good in the sense that you don't have to set it like per data center, but I think that's something you want. I don't know that you'd want a data center that you could provision with only like 8 gigs of RAM or something. I don't know.
Well, yeah, I mean, just to be a little resource light, but then you could also pick your storage class, which is more or less linked to how Kubernetes goes. Again, we're separating compute and storage here.
Right.
I'm just going to pick standard core, and 2 gigs is fine
good
now.
Yeah. I think standard is technically the equivalent of spinning disk, so maybe it's good for dev, but I don't know that I'd go beyond that. But
again, in the docs we have resource planning, and that's the one you pay attention to. Yep. Now, if you make a mistake, it's okay, because you could always change things up. You can always, because this is Kubernetes, you can update and say, oh no, instead of 8 gigs of RAM, I want 16, and it'll reprovision pods, it'll do some shuffling if you need to add more storage. I mean, there's options, but this isn't like ordering a server off of Dell. That's what you get.
And then what you get.
Yeah. Sorry, that's what showed up. And then we have this business of authentication to the cluster. Let's walk through this real quick. Now that's
so Kubernetes. I mean, basically you can define it's just kind of like starting a Cassandra cluster. When you normally provision a Cassandra cluster, one of the first things, I mean, at least that I do, is go ahead and create a new super user account, and then change the password on the Cassandra one.
I'm going to use the word password because no one guesses. It's security through obscurity. Right. Yeah. No. Right. But I mean, I have to put in a password here.
Right.
And then right now it's going to be this username, because I don't get to change it. Right. Or I can just turn off required. And this is a powerful but interesting little slider here. This enable internode encryption. Let's dig into that. So tell us a little bit more about what's happening there.
Well, basically, that determines whether or not you want to use internode TLS certificates. And the cool thing is that Mission Control will manage the life cycle of your Cassandra certificates, which, to be honest, is super awesome. I remember having, this is probably 10 years ago now, but I remember having to take a partial outage on a cluster so that I could update the certs on it one data center at a time as I went along. And I remember that was just not fun for anyone.
That's why I said this is such a powerful little slider. I mean, it seems so innocuous, but it's like those of you who've done this, you will rejoice, because it is a big deal. And it uses Cert Manager behind the scenes and Acme, which is, if you don't know about that, it's such a major ROI enhancement, because not only does it handle the provisioning of certificates, TLS certificates, it also does the rotations and just keeps everything moving. And no security people will be upset you using Cert Manager ever.
Right.
And then, all right, so backup and restore. I feel like that's something we can touch on. I'll let you do that.
Yeah. So the prefix is basically, when you run a backup or have a backup scheduled, that's how it's going to, kind of prefix the file names that it sets up, and the directories too. I think I'd have to check that. Backup configuration, that's something that you have to set up special. Now, you absolutely can create a new cluster of HCD or whatever inside of Mission Control without a backup configuration. That is the cool thing, kind of like you mentioned, Patrick, that, hey, if you have to go back and modify later, that's one of those things that's really, really easy to do. But the idea is that you create a backup configuration that's aware of things like your underlying bucket storage and maybe your service account JSON, and can actually go and kind of tie together the back end of where those backups and restores have to happen from. So that's really what that's all about. But yeah, we can I actually have a video on that where I go through kind of setting that up. But yeah, we can skip that for now. But it's definitely something that I know a lot of people maybe don't back up their Cassandra clusters either. But it's an easy way to set it up and give you that extra ability to recover from some kind of like data disaster. So
hey, there's two types of users out there: those who have lost data and those who are about to. I keep saying the backup for Cassandra. I've said this for a bazillion years. Backups in Cassandra are not about data, like losing a cluster. It's about what your users wound up doing to your data, like data corruption. You can back out of, I mistakenly, I've been there where I've had people like, somebody wrote some code that wiped out like a ton of records. Well, go back to, you can easily restore that from the backup. And because of the idempotency of Cassandra data, it's easy to restore.
Mm-hmm. Yep.
All right, cool. And then of course, heap. And if you know, if you don't, read the little docs about this. 25% is recommended, but you may want more. That's totally cool.
Yeah, I usually go 50% of RAM to heap. So that's just me though.
Right on. Let's go 50%. Let's do it. Live a little, right? Yeah. And then this, have you done a video on this yet?
On which one? Adding an external data center? I have not touched that one yet.
Thanks. I think, well, there you go. There's your next thing. But that's actually a pretty cool thing. And of course, it'd be adding the seeds for that. Is a really important part. The superpower of Cassandra, there are three things that we started from the beginning of Cassandra project back in the day when it was just a little sprout coming out of Facebook, which is, scale, which is most, scaling linearly, which is important, linear performance, and then also distribution. Like we will never have a Cassandra database that can't distribute across multiple data centers and be active. That just is that's a sacred right. So yes, and we maintained it. Good. So stay tuned for that one. That'll be a really good one. It's in the docs, of course, but I think a video from Aaron would be really sweet. And then finally, deploy
data API. Yes or no? That one's pretty simple. Yeah.
Yeah. The yes is based on how you want to present this to your developers, and we'll go into it a little bit. So I'm just going to create this puppy. All right. So once I click the go button, it goes through this thing where it's now provisioning. You can see where it's provisioning nodes behind the scene. And it's provisioning 3 per rack as I asked it to. This is all happening over in my Google area here. I can probably see it firing up right now pretty soon. This is in Google Cloud. This is actually what's running part of this right now. So, but that was a peek behind the curtain. We don't need to do that. But I think what we should do, Aaron, is let's go look at your project. And you have a lot of stuff going on here that's good to kind of point out. So
yeah. So Test for Echo is probably the better example here. I'm a bit of a fan of the band Rush. So all of my clusters are named after Rush albums, and the data centers are named after songs, and because Rush has played since, the early 70s and actually before that, but, there's no end to material that I could use there. So, yeah.
Wow. Well, let's look at some of the stuff that's in here. Well, first of all, these are all running clusters.
Yeah.
And those are two different data centers. Yeah.
Yep.
And these are running...
I think I made each of those on HCD 1.0. I think those nodes are 8 gigs each with RAM and then 4 gig heaps. And I think they're running, it's either 10 or 20 gigs of disk. I forget. Oh, yeah, it looks like 20. Yeah. Oh, yeah. Oh no.
10 gigs.
10. That's it. Yeah.
And then, and then you had a 6 gig heap on 16 gigs. Yeah. Oh, hey man, you can make up whatever you want, but the numbers don't lie.
The numbers don't lie. Oh, you're not wrong there. Yeah.
But it gives you this. It gives you a lot of stats, like thread pool stats. These are things that come out of like node tool stats.
I was going to say things you'd normally have to go to node tool for. Yeah, and it kind of puts it. Mission Control puts it all in one place, which is really cool.
I think the other thing that most people want is pretty graphs.
Yep. Yeah, and again, you can see most of all of the important things are going to be here. Note that with mission control, you can actually we went over this yesterday with Chris Bradford. You can actually ship your logs from your clusters in mission control to an external observability suite. So we have customers that do this with like Prometheus. Grafana is another popular one too. Actually, I've come to understand that that mission control comes with Grafana. You just have to know how to turn it on.
Yeah, there's so much good content to be made, and I saw Brian Fisher was in the chat. Brian works on our doc team, and I think he'll be doing some really interesting doc dives on connecting to external resources like Datadog or your Prometheus cluster that you already have. And that, I think that's a really important point to make, is observability is almost religion, man. It's like, this is what I do. This is what our team uses. Don't tell me to do something different.
Yep.
And even worse, don't be an island. Yeah, these are neat and pretty graphs, but I want it on one place. So we heard you. We got that.
Yep. Yeah. Yep. And you can set up like custom syncs as well. I mean, you can send it to like Datadog if you want to. Or if you're rich, you can send it to Splunk.
or very, very, very poor. Hey, man,
there's a way to customize that and kind of bring your own observability into mission control as well.
Yeah, no, I love Splunk. I mean, we use Splunk at DataStax for our cloud, and I mean the amount of statistics you can get out of that thing is just crazy.
Yeah. I used it before at Target. It's cool, but it's a little pricey.
It's a programming language. It's a storage medium. No, it's both. We'll go into the Connect a little bit later. That's this is very similar to how Astra works, where it gives you like how to do different languages, and we'll go in that in a minute. But I think let's get into this into day two things here. So like backup. So you wanted to want me to click into something?
So what do you want me to do? I actually for this is the cluster that I use to make my backup and restore video that I came out with a couple of weeks ago. So the backup activity that you're seeing here is just for let's see here. Yeah, I didn't schedule it. It was a one-off backup. It was like, hey, go ahead, create backup, kind of a thing. Sorry, what?
I can look at a different cluster if you want to look at the schedule.
No, this is good. This is good.
Okay.
And actually, it's probably better if you have a look at the activities tab in the left nav there.
Mm-hmm.
There you go. So so what you can see is the different backup operations that have run. I think one of those is a restore that I also did, and I think I have one on my other cluster that's kind of hung up there as well.
Yeah, permanent waves is permanently backing up. Yeah.
But that's the thing. We're I was going to say, where we go back to talking about how mission control gives you things you'd normally see in Node Tool. This saves you from having to do like a what is it, like a Node Tool compaction?
Yeah,
Node Tool compaction stats, I think. Oh, wow! It's been so long since I typed it.
Yeah.
Yep.
No, not Node Tool compact. Don't do that.
Node Tool compact. No. Don't do that.
Okay, let me go back to your cluster.
Yeah, and then if you go back and then test for echo and then say repairs.
Oh, repairs.
Unless you're looking for something else, but
no, repair is good too.
Repairs are good too. Yep.
So
yeah, repairs are things that of course you can schedule, or you can run a one-off. I'm pretty sure. Oh, I do have a schedule. Look at that.
I'm just gonna click over and see. Yes.
I couldn't remember if I'd created a scheduled repair or not, but yep.
Yeah, and it's really
repair. That's important.
I think this is really the cool thing. This is the ROI part. Is you can a lot of those day two operations, the backup repair, you just set up schedule and let it run, and it just works, and there's some great configuration for it. So I'm sure if you're running Cassandra clusters, I'm sure you already have a processor too. But this is one that really
maybe you're using Reaper. I know that's something that we've set up before.
Yeah.
But again, this is Reaper under the hood, and you don't have to set it up. It's just kind of there.
Yeah, you can see the nodes running there. Well, great. I think this is what I wanted to show here. Should we switch back over and talk about some of the so I think we're at the point where, okay, so let's make sure my cluster's set up. Let's not leave everyone hanging. Yay! It's there. It's starting. It's still starting.
Oh, you got 2 nodes up, right?
Yep.
Is that one in each? Oh, it's 1 DC at a time. Okay. Or is it?
Yeah. Well, it's doing 1 rack at a time. So it's setting
1 rack at a time. That's it.
Because it has to do the token ranges. So.
Yep.
As prescribed by the documentation, it's starting up in a very orderly manner. Well done, Mission Control. So once we walk through like what HCD is. So like, why would you even want it? And Dan is waiting for 5.1, so I'll go talk to the dev team immediately. Look, let's hook up Dan. I'm just gonna have that.
Absolutely, yeah.
And
we got you.
Yeah, we got you, man. And then we talked about like what do you do? Like, how do you provision it? So let's talk about like, all right, what's next is let's let our developers connect to it. So let me switch over to that.
Yeah. Jump back to the
old slides here. Hang on.
Yeah.
Over to these slides that shows it's this thing.
Hey, there we go. So before getting into connecting up and how you do that, hey, just a quick talk about like HCD, and especially when you run it through when you're using it through Mission Control, well, you have this basic component, which of course is your HCD cluster that that has all of your nodes. So Patrick, if you click there, you'll notice that the cluster nodes all have like internal IP addresses. And those are things that, typically, you would expose so that your dev teams can go ahead and use that. Or if you're running Cassandra in a Kubernetes world, you'll probably stand up a load balancer. So you can go ahead and click. And one more.
I feel like I'm provisioning load balancers now. That's great.
Right. So basically, yeah, it's simple. It's I'm sure everyone, kind of knows this stuff already. It's putting your nodes behind a load balancer or a virtual load balancer or whatever to kind of forward those requests along, making sure that it's getting to the nodes that it needs to get to. But the other thing, if you go ahead and click next, we also have the data API. And the data API kind of runs as its own service, and Kubernetes world, it runs also as its own pod that can be exposed. And in this way, you can decide, hey, with HCD, well, maybe I still want to use CQL for my applications or for new things that I'm building. Maybe I have a lot of things that have been running on Cassandra for a couple of years, and 9042 is going to work perfectly. Or if you want to use the new data API paradigm, you can use that as well, as long as you kind of expose that, and then you can connect to that on port 8181.
And real quick, data API equals Mongo compatibility.
Yep.
Yeah.
Yep. It's working right. It's working with it in a document database paradigm. That's right.
Yeah. So developers who are building on Mongo will have zero problems working with the data API. Maybe you want that. You probably do.
Maybe you want that. Yeah.
So let's get into, all right. So, and that's the thing, is this is Kubernetes. And so this is so funny. Like at KubeCon, there's plenty of talks about like, I've set up a Kubernetes cluster. How do I get to it? Yeah. You don't connect directly to the nodes anymore.
Nope. But yeah, the probably the most key thing on this slide is that big, bold purple depends on infrastructure.
Yeah.
But bottom line, yes, you want to make sure that that you're exposing those ports of 8181 for the data API and 9042 for CQL. And those are going to be, in a Kubernetes world running on different pods. So, of course, if we go ahead and look at the next slide, you can see this is the command line hacky way to do it with a port -forward via kube control, specifying the to port and the from port, and then your namespace. So
yeah, it's not hacky. This is the way it works, man. It's just, you want that fluffy front end, go ahead. Although load balancers are, that load balancers per cloud provider, that's a built-in thing with all their Kubernetes stuff. So you wouldn't have to worry about it too much. And they have infinite scale. They're just amazing how much you can get out of a load balancer.
Yeah. Right. So when you authenticate up, you can still go the old way, like I said, of using 9042 CQL binary protocol, and that takes your Cassandra username password that you're used to, or you can generate a token, and actually you can use. I'm pretty sure you can use a token. Oh, maybe I'm not correct on that. Maybe I think it's just for the data API. I don't know that you can use. Well, or is it? Would a token work straight up with HCD using CQL? I don't know that it would. I mean, I know it's technically what we do with Astra, but
because it uses Astra pod.
Yeah. Right.
I'm going to say it confidently, yes, and that may be a ChatGPT response.
Right.
But I believe with the new driver, it can take a token. But it's worth making sure. I know you have a video about part of this.
I do have a video about part of this. Yeah. That actually, I talk through the next slide that you're going to see too. So of course, if you use Cassandra for a while, you're probably wondering, well, okay, I know where I get my username and password. Where do I get a token from? Well, so essentially you can compose your data API token from this little kube control command, which basically what it does is, pulls out pulls out your super user from the secret store and gives you the base 64 encoded username and password. So if you go on a little, Patrick, one more.
Does it really have blah in the password? That's so weird.
No, that's my way of not getting yelled at by our security team.
And we do. Yeah. Anytime we put a token up, we get an immediate email.
Yes, we do.
Yeah.
So if you run this command, it's going to give you back the base 64 encoded username and password. So my username is Permanent Waves super user, but it'll come back from this command as 64 base encoded. And then basically you just put it together with a string of Cassandra, capital C, and then colon, your base 64 encoded username, colon, base 64 encoded password. That constitutes your token.
This is a lesson we learned in Astra is developers prefer this, and it's easier to work with when you have like a application-based token, and you can put different, for operators, it means that you can give out tokens that have certain permissions and that everyone uses the same thing. Don't put this in your public repo, but it's out there, and you can revoke the token, and it's instantaneous. Unlike having to go through the username and password, people typing passwords into everything. Tokens are much easier to work with.
You're absolutely right in that people so much prefer this. I remember when I first started at DataStax with Astra, we were still using to connect up, you needed the database ID, you needed the region, you needed your I think it was a user ID, and then a secret, and then your secure connect bundle. No, now we just do token, and it just does it all.
It does it all.
It's definitely the way to
now you can connect to your stuff. So you built, you know what it is, you can build one, and you can connect to it. I think at this point you should just go try it out. We have
I think
we have some resources for you. I know, don't worry about typing this. This is just for later, but it'll be in the description, and I believe Michelle's putting them in this.
Yep.
Link
Michelle's
as
going to
well.
get these out there. Yep.
Yeah. So I mean, the YouTube playlist. If you didn't get enough Aaron today, there's more. But Aaron, I really appreciate this playlist, and just to let everyone know, the reason I appreciate it is because you turned it into these little nuggets, these bite-sized chunks. Like, do a backup, do a repair. You know, each video is a separate topic.
Use a data API. Yep.
Yeah.
Build a cluster. Yep.
And he's cranking out more and more of these, and we came up with a couple a day.
We did. Yeah, for sure.
Yeah, and our HCD docs are getting beefed up at a really rapid pace. Like I said, shout out to Brian, I know he's watching. He just waved at us on the chat. But Eric Ramirez, many of you know from the Cassandra community, he's also pretty involved in the HCD docs. I mean, and feedback is important. If you see something that's missing on any one of these, we want to hear it, because we know we got stuff to build and there's more to talk about. There's never enough. So always, you can find us in the usual places. Just looking at my LinkedIn, I see many of you found me on LinkedIn. Great. Aaron, I think we're both pretty also active on the ASF Slack.
Yep, that's right. But yeah, that's a good call out about the docs, Patrick, and that if you see something in docs that doesn't quite look right or isn't working for you, let us know. Just because there's a lot of times that we see this stuff every day, and when we see stuff in the docs, we may glaze over it because we really kind of know, how to go about it anyway. So the docs may not mean the same to us as they do to you, I guess is kind of what I'm saying. So if you see issues, they may be things that we just gloss over because we see them every day. So,
and what's really cool is this is very different from like a lot of open source projects where they're like, oh, you found something broken in the docs? Well, we'll take a PR. No,
right?
This is awesome because you can just tell us, and we have people. We'll do it.
We'll just take care of that.
Yeah. So that's nice. Don't hesitate. Just say it. Get it out there. Cool. All right. I think we are done. Again, we're out there in all the places where you like to be. We're in Slack. We're at a few different places. So please, LinkedIn, connect with us. Tell us about what you're working on. If you have any questions, we're more than happy to get on a Zoom with you. We have some links that you should follow for sure. If you want a free consultation, meaning working with one of our solution architects to talk about HCD, how does it work in my environment? Like, here's my Kubernetes environment. Here's how I want to run Cassandra. Maybe you don't want to run HCD. Maybe you want to run Cassandra a different way. Talk to us. We've got a lot of options. But in 2024, we have a lot of options because we have so many options, right? There's cloud, there's not cloud, still not going to run it on Raspberry Pi. Don't ask. But
actually, we have some cool videos about that too, if you go look.
Yeah, it's fun, but not in production. But yeah, just sign up for there's on our homepage, there's a sign up for a free consultation. We'd love to talk to you about it and see where you're up to. So and I would be happy to join that call. Aaron will join that call. So
absolutely.
Great. Thanks everyone, and we'll see you in the next workshop.
All right. Hey, thanks everyone.
All right, good.